Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on standard form. If you need any extra help on standard form, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video numbers 300, 301, 302 and 303, there's dedicated video tutorials there on standard form. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one says to write in standard form 35,000. Okay, so if we want to write a number like 35,000 in standard form, remember we want to write it in the form a multiplied by 10 to the power of n, where a is between 1 and 10, so it's greater than or equal to 1, but less than 10. So it needs to be a number such as, in this case, 3.5. So we're going to choose 3.5 in this case, because that's a number between 1 and 10, which we would choose here. And then we're going to have multiplied by 10 to the power of. Okay, now we just need to work out the power. And in terms of the power, we just need to figure out if we've got 3.5, what you'd need to multiply that to get 35,000. Would it be 10 squared or 10 cubed or 10 to the power of 4 and so on? So if we consider our 3.5, how many columns would we need to move these digits to move the 3 from the ones or the units column into the tens of thousands column, and the 5, which is in the tenths column, into the thousands column? So the 3 would move. If it was in the ones or the units column, it would move 1, 2, 3, 4 columns to the left, so it'd be 10 to the power of 4. And likewise, if the 5 was in the tenths column, we'd need to move it 1, 2, 3, 4 columns to get it into the thousandths column. And that's it. And let's just consider this. If you have 3.5 multiplied by 10 to the power of 4, 10 to the power of 4 would be 10,000. And if you do 3.5 times 10,000, you get 35,000. And that's it. So it'd be 3.5 times 10 to the power of 4. And that's it. Okay, let's look at part B. Part B says to write as an ordinary number 1.2 multiplied by 10 cubed. So we need to write this as an ordinary number, so we need to write it out in full. So here we've got 1.2, and we're multiplied by 10 to the power of 3. Now here I look at the power, which is 3, and that means we're going to move these digits 3 columns to the left. So the 1, which is in the units, or the ones column, will move 3 columns to the left. So to move into the tens, the hundreds, and then the thousands. So that means the 1 will move into the thousands column. The 2, which is in the tenths column, it will move 3 columns to the left, so to move into the ones or the units, and then into the tens, and then into the hundreds. So we're going to have 1,200. And let's just check that. If we had 1.2 multiplied by 10 cubed is 1,000, and 1.2 times 1,000 would be 1,200. And that's it. So if I had 1.2 times 10 to the power of 3, I would just move these digits 3 columns to the left. And just to recap part A, if we had 35,000 and we wanted to write that in standard form, I'd write 3.5 because that's a good number to choose between 1 and 10. And then if we've got 3.5, we'd need to move those digits 4 columns to the left to get 35,000. So that'll be times 10 to the power of 4. Okay, now let's have a look at our next question, question number 2. So question number 2a says to write in standard form, and we've got this number, let's just have a look at it. So if I was to put commas in, I'll put a comma there and a comma there. So we've got 8,200,000. So we've been asked to write 8,200,000 in standard form. So in terms of a number between 1 and 10 we're going to use, I'm going to choose 8.2, so 8.2, and then we're going to have times 10 to the power of. Now we just need to figure out the power. Okay, so let's consider how many columns we would need to move these digits to the left. So here we've got the 8, which is in the units, so the ones column, and if it was here in the units or 1 columns, we'd need to move it 1, 2, 3, 4, 5, 6 columns to the left. So it'll be times 10 to the power of 6. So if we're asked to write 8,200,000 in standard form, it would be 8.2 times 10 to the power of 6. And that makes sense because 10 to the power of 6 is a million, and 8.2 times a million would be 8,200,000. Okay, now let's have a look at part B. Part B says to write as an ordinary number 4.7 times 10 to the power of negative 2. So we've been asked to write it as an ordinary number, so that means we need to write it out in full. So here we've got 4.7. Now we're timesing by 10 to the power of negative 2. So this time we're multiplying by 10 to the power of negative 2, so it's going to get smaller. And because of the power is negative 2, we're going to move these digits 2 columns to the right. So the 4, which is in the units or the ones column, will move into the tenths and then into the hundredths. So the 4 is going to move into the hundredths, and the 7 will move 2 columns to the right, so to move into the hundredths and then into the thousandths. So it's going to be 0.047. And let's just check that. If we had the 4 in the units or ones column, if we moved it 2 columns to the right, it would move into the hundredths column. And the 7, if it was in the tenths column, if we move it 2 columns to the right, it would move into the thousandths. And that's it. Now, one thing I'm just going to mention here is that a student once told me a bit of a shortcut whenever you're doing these 10 to the power of negative numbers, such as 10 to the power of negative 2. She said whenever it's going to get smaller, like when you've got 10 to the power of negative 2, you can just look at the power and put that number of zeros in front of the digits you were given. So we were given a 4 and a 7. The power is negative 2, so we're going to put 2 zeros in front of it, and you're going to put your decimal point in. So it'll be 0.047. If it was 10 to the power of negative 3, you'd put 3 zeros in front of the 47, and then you'd put the decimal point in, so it'd be 0.0047, and so on. So it's just a bit of a shortcut that student mentioned to me, and it stuck with me. Okay, now let's look at our next question, question number 3. So question number 3, we've been asked to circle the number in standard form. So one of these numbers is in standard form, and we need to circle it. So remember, for a number to be in standard form, we're going to have a, so that's a number that's greater than or equal to 1 but less than 10, times 10 to a certain power. So it needs to be in that form. So first of all here, I can see we've got a plus sign rather than a multiply, so I'm going to rule that one out. That's not in standard form straight away. This next one, well, the number needs to be bigger than or equal to 1 but less than 10, but this is 36, so no, that's too big. The number can't be 10 or greater, so it's not going to be that one. This one here, 0.3 times 10 to the power 5. Well, good has got the times 10 to the power 5, so it's got the multiplier, but the number needs to be bigger than or equal to 1 at the front, so that one's not going to be standard form either. And that means that this one will be in standard form because we've got a number that's bigger than or equal to 1 but less than 10, 6.5. And then we've got the multiplier and then 10 to the power of 8, so that number is in standard form. And that's it. So that one's the number that's in standard form. Okay, let's look at our next question, question number 4. So question number 4, we've been asked to write the following numbers in standard form. So part A, we've got 40,000. So in terms of the number between 1 and 10, greater than or equal to 1 but less than 10, I'm going to choose 4, and then times 10 to the power of. Now if the 4 is in the units or the ones column, we would need to move it 1, 2, 3, 4 columns to the left. So it's going to be to the power of 4. Okay, let's look at our next part, part B. So our next one, we've got 5,600, and we need to write it in standard form. So the number between 1 and 10 that I'm going to choose is 5.6, so 5.6 times 10 to the power of. So if we have 5.6, the 5 would be in the units column, so here, and we need to move it 1, 2, 3 columns to the left. So we would have times 10 to the power of 3. And let's just check that. 10 cubed is 1,000, and 5.6 times 1,000 would be 5,600. So that would work. Okay, next, part C. Part C, we've got this number, and let's have a look at it. I'm just going to put some commas in to help me read it. So 41,200,000. So if we wanted to write 41,200,000 in standard form, the number we're going to choose, the number at the front that we're going to multiply by 10 to the power of something will be, now it needs to be bigger than or equal to 1, but less than 10. So I'm going to choose 4.12. And then we're going to have times 10 to the power of. Now if the 4 was in the units column, we would need to move it 1, 2, 3, 4, 5, 6, 7 columns to the left. So it'll be times 10 to the power of 7. And let's just check that. 10 to the power of 7 would be 10 million, and 4.12 times 10 million would be 41,200,000. So that's it, that's right. Okay, our next one, part D. Part D, we've got this number, which is 0.0000008 or 0.000 and so on, 8. And we need to write that number in standard form. So the number between 1 and 10 we're going to choose is 8 times 10. Now there's a couple of approaches that we can choose here to get this power. One approach is to use that shortcut that I mentioned earlier that a student recommended to me, and they said, well, whenever you've got a number such as this where it's, the power is going to be negative because it's less than 1, it's a 0.00 and so on number, you can just count the number of zeros. So 1, 2, 3, 4, 5, 6, 7, 8 zeros, so it'll be to the power of negative 8, and it's negative 8 because remember that it's a smaller number, it's getting smaller, so it's going to be the negative power. You're moving the digits columns to the right. So that shortcut is just count the number of zeros, and that'll be the power, obviously a negative power. And that's one approach. Another approach would be, well, if we started with 8, it'd be in the units column, and we would need to move it 1, 2, 3, 4, 5, 6, 7, 8 columns to the right, so it'll be to the power of negative 8, and that's it. Okay, next one, part E. Part E, we've got 0.00345. So in terms of the number between 1 and 10, I'm going to choose 3.45 because we've got those digits there, so 3.45 times 10 to the power of, and we know it's going to be a negative power because it's less than 1, it's a 0.00 and so on number, so it's going to be a negative power. And again, the two different approaches is just count the number of zeros, so we've got 4, so it'll be to the power of negative 4. Or another approach we could say is here, if we've got 3.45 and we're timesing it by 10 to the power of something, well, the 3 would be in the units column and we would need to move it 1, 2, 3, 4 columns to the right, so it would be to the power of negative 4, and that's it. Okay, let's look at our next question, question number 5. So question number 5, we've got this number and we need to write it in standard form. So let's put our commas in definitely here. So a comma there, a comma there, a comma there. So 37,341,000,000, and we need to write that in standard form. Okay, so if we've got 37,341,000,000, we want to write it in standard form. The number at the front, the number that's bigger than or equal to 1 but less than 10 will be 3.7341. 7341 times 10 to the power of, and then if we've got the 3 here in the units of the ones column and we need to move it to here, we would have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns to the left, so to the power of 10. So just to recap there, we had 3.7341 because they're the digits there, and then the 3, which is in the units of the ones column, it would be here, and we just count the number of columns we'd need to move it to the left. So if we multiply that by 10 to the power of 1, it would move 1 column to the left, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, 10 to the power of 6, 10 to the power of 7, 10 to the power of 8, 10 to the power of 9, and 10 to the power of 10. So it needs to move 10 columns to the left, so that's why it's 10 to the power of 10. Okay, let's look at our next question, question number 6. Okay, so question number 6 says, Nadal has been asked to write the number, and then we've got this number in standard form. So let's have a look at it, just put the commas in to help us read it. We have got 48,100,000, and he's been asked to write 48,100,000 in standard form, and he writes 481 times 10 to the power of 5, and we've been asked to explain why Nadal is incorrect. Well, first of all, he's been asked to write it in standard form. And a number that's in standard form will have to have a times 10 to the power of something. So here, the a needs to be, this a needs to be greater than or equal to 1, but less than 10. So it needs to be bigger than or equal to 1, but less than 10. But he's got a number there, which is 481. And 481 is obviously bigger than 10, so that number is not in between 1 and 10. So Nadal is incorrect, that number is not in standard form. So let's explain that. And that's it, we just explain that Nadal is incorrect because 481 is not less than 10, so therefore it's not in standard form. Actually, if we wanted to write this number in standard form, let's have a look at it. We would have 4.81, because that's the number between 1 and 10 that we would choose, times 10 to the power of. And if the 4 was in the units column, we would need to move it 1, 2, 3, 4, 5, 6, 7 columns to the left, so to the power of 7. And that's it. So that's the number he should have written, 4.81 times 10 to the power of 7. But he didn't. The number he chose at the front was 481, which is not in standard form. Okay, question number 7. So question number 7 says, Amelia has been asked to write the number 0.0054 in standard form. And she writes 5.4 times 10 to the power of 3. Explain why Amelia is incorrect. Okay, so let's have a look at Amelia's answer. Well, actually, Amelia's done well to begin with. She's written 5.4, and 5.4 is greater than 1, but less than 10, so that's good. But she's got times 10 to the power of 3. Now, if you go 5.4 times 10 to the power of 3, it's going to move those digits 3 columns to the left, because the number's getting bigger. You times it by 1,000, so you're going to get 5,400, and that number is not 5,400. Amelia actually wants to move these digits to the right, because this is a small number. It's 0.0054. And the 5 here, if we wanted to move it to get to here, at the minute it's in the units of the ones column, it would need to move 1, 2, 3 columns to the right. So it shouldn't be to the power of 3, it should be to the power of negative 3, because it's a smaller number, it's less than 1, it's a 0.00 and so on number. So there needs to be to the power of negative 3, not 3. So let's explain that. And that's how I've just explained that the power should be negative 3, not 3, because 0.0054 is 5.4 times 10 to the power of negative 3, not 3. Okay, let's have a look at our next question, question number 8. So question number 8a says, write 1.52 multiplied by 10 to the power of 6 as an ordinary number. So we want to write this out in full. So if we've got times 10 to the power of 6, that means we're going to move the digits 6 columns to the left. So the 1 would move 6 columns to the left, the 5 would move 6 columns to the left, and the 2 would move 6 columns to the left. So what I'm actually going to do is I'm going to move these digits 2 columns to the left to begin with. That'll be 152, moving the 1 into the hundreds, the 5 into the tens, and the 2 into the ones of the units column. So just move the digits 2 columns to the left. Now I want to move them another 4 columns to the left, so I'm going to add 4 zeros. 1, 2, 3, 4. And that means that we move the 1 from the units to the ones column 6 columns to the left. 1, 2, 3, 4, 5, 6. So that's it. That's our answer. 152,000,000 or 1,520,000. Okay, next, part B. Part B, we've been asked to write 9.8 times 10 to the power of negative 5 as an ordinary number. So again, we want to write this out in full. Because the power is negative, it's going to be a very small number, 0.00 and so on number. Now here, with the power is negative 5, so as the student told me in class, I recommended that if you got a power of negative 5, you could write 5 zeros, 1, 2, 3, 4, 5, and then put on the 9 and the 8, and then just put the decimal point in. So that would be the answer, 0.00009. Or another way to think of it is we're going to move these digits 5 columns to the right, so the 9 would move from the units into, let's just check, 1, 2, 3, 4, 5 into that column, and so on. So that's it, we've written that as an ordinary number. Okay, let's look at our next question, question number 9. So question number 9, we've been asked to write 0.000000000. I think I've said the right number of noughts there. 412 in standard form. So in terms of the number between 1 and 10, I'm going to go for 4.12. That's a good number to choose between 1 and 10. Multiply by 10 to the power of. That's a very small number, so we're going to put a negative power. And if we use that technique that student recommended to me, just count the number of zeros here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 zeros, so it'll be to the power of negative 13. Or another way to think about it is if we had 4.12, if the 4 was here in the units column, how many columns would we need to move it to the right? It'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we've moved the digits 13 columns to the right. And that's it. Okay, let's look at our next question, question number 10. So question number 10, we've been asked to write 375 times 10 to the power of 6 in standard form. Now this number is not in standard form. It looks like it because we've got the times 10 to the power of 6, but the number at the front isn't between 1 and 10. So what we would need to do is if we had 375 times 10 to the power of 6, the number at the front should be 3.75 because that's a number between 1 and 10. And then we're going to have times 10 to the power of. Now here, if we make this number 100 times smaller, we divide this by 100, we're making it 100 times smaller, we need to make this number 100 times bigger so that we still get the same answer. So instead of being to the power of 6, you would times that by 100, so that means you'd have 2 more zeros, so it'd be to the power of 8. So what we've done here is we just said, well, if these two multiply together to give us a certain number, if we divide one of the numbers by 100, if we're dividing this one by 100, to get that number, we're going to need to multiply that one by 100 so we get the same answer. And if we make this 100 times bigger, it would add on 2 more zeros, so it'll be 10 to the power of 8 rather than 10 to the power of 6. So the answer would be 3.75 times 10 to the power of 8. And that's it. So if you've got a number that looks like it's in standard form but not, and you need to perhaps multiply or divide the first number by a certain amount, you then just need to think, well, what would you need to multiply or divide the other number by that you would still get the same answer? And in this case, if you divide this number by 100, and as you can see we've divided it by 100, then you need to multiply this number by 100. So that'll be your answer. Okay, now let's look at our next one, question number 11. So question number 11 says to write 0.68 times 10 to the power of 12 in standard form. So again, this isn't in standard form because this number needs to be between 1 and 10. So instead of being 0.68, we're going to write 6.8 because that would be between 1 and 10. But we've made that number 10 times bigger. And if we've made that number 10 times bigger, we're going to need to make this number 10 times smaller. So instead of being 10 to the power of 12, if we divide by 10, it'll be 10 to the power of 11. It would take off one of the zeros because 10 to the power of 12 is 1 followed by 12 zeros. If you divide that by 10, you'd have 1 followed by 11 zeros. So the answer would be 6.8 times 10 to the power of 11. And that's it. That's question number 11. Okay, so let's have a look at our next question, question number 12. So question number 12 says, write 92 multiplied by 10 to the power of negative 8 in standard form. So this isn't in standard form because the number at the front needs to be between 1 and 10, so bigger than or equal to 1, but less than 10. So to make it in standard form, what we're going to do is instead of writing 92, we're going to write 9.2. So we're going to make that number 10 times smaller. We're dividing by 10. So we're going to make that number 10 times bigger because if we make one number 10 times smaller and the other one 10 times bigger, when we multiply them together, we'll still get the same answer. So whenever we make a number 10 times bigger, we're going to increase the power of 10 by 1. So instead of being to the power of negative 8, it's now going to be to the power of negative 7. So 92 times 10 to the power of negative 8 in standard form would be 9.2 times 10 to the negative 7. We made that number 10 times smaller, and we made that number 10 times bigger. And whenever we made 92 10 times smaller, it was 9.2. And whenever we made 10 to the power of negative 8 10 times bigger, we increased the power of 10 by 1, so it became 10 to the power of negative 7. And that's it. Okay, let's look at our next question, question number 13. So question number 13, we've been asked to write these numbers in order of size, starting with the smallest. So we're going to go from smallest to largest. So let's write these numbers as ordinary numbers. So 250, that's great. Let's write the other three numbers as ordinary numbers. So we've got 2.04 times 10 to the negative 3. So that means we're going to move the digits 3 columns to the left. So the 2 will move into the tens, then the hundreds, and then the thousands. The 0 will move into the hundreds, the 4 would move into the tens, and we'll need a placeholder there. So it's going to be 2040. And let's just check that. If we had the 2 here in the units column, and we moved it 3 columns to the left, it would move 1, 2, 3. And there would be 2040. Alternatively, we could think of it as 10 cubed is 1,000. 2.04 times 1,000 would be 2040. Okay, 250, well that's an ordinary number already. We've then got 0.3 times 10 to the power of 3. Now that's not in standard form because this number here would need to be bigger than or equal to 1 and 0.3 isn't. But let's write it as an ordinary number anyway. So we're timesing by 10 to the power of 3. That means we're going to move the digits 3 columns to the left. So the 3, which is in the tenths column, will move into the units, then the tens, and then into the hundreds. So that'll be 300. And here we can check that. 10 cubed is 1,000 and 0.3 times 1,000 would be 300. Okay, and our last one, 4 times 10 to the power of negative 2. Now that number is in standard form, and because the power is negative, it's going to be a very small number. It's going to be 0.0 something. So here we've got 4. Now because the power is negative 2, we could either consider it as moving this 4 2 columns to the right. So it would move into the tenths and then into the hundredths. So it'll be 0.04. Alternatively, like I mentioned a few times before, as that student said, whenever you get a power of negative 2, you can just put 2 zeros in front of the number 4 and then just put the decimal point in, so it'll be 0.04. And that's it. So we've been asked to write these numbers in order of size from smallest to largest. So this is the smallest number. And I'm going to write down what we were given in the question. So 4 times 10 to the power of negative 2. So we've done that one. Our next smallest would be 250. Our next smallest would be 300, so that'll be 0.3 times 10 cubed. And the biggest number would be 2040, so that's going to be 2.04 times 10 cubed. And that's it. So we've written those numbers in order, starting from the smallest, going from smallest to largest. Okay, let's look at our next question, question number 14. So question number 14, we've been asked to calculate and to write our answer in standard form to this. So we've got 2.05 times 10 to the power of 5 multiplied by 8.17 times 10 cubed. Now, whenever I'm typing this into the calculator, first of all, it's important that you know where your standard form button is. On my calculator, that button's in the middle of the bottom row, and that's the standard form button. And also, whenever I'm dealing with standard form on my calculator, I like to include brackets. So I'm going to open up my brackets, type in 2.05, press the standard form button, and then type a 5 in as the power. Then I'm going to press to the right and then close brackets. And then I'm going to press multiply by, and then open up brackets and type in 8.17. Press the standard form button again, and then put a 3 as the power, and then press to the right and close brackets and press equals. And my answer is shown as an ordinary number as 167485000. Your calculator may give the answer in standard form, but mine's given it as an ordinary number. So I need to write my answer in standard form. So in terms of a decimal number between 1 and 10, I'm going to choose 1.67485. Just write down that part with the decimal point in there. And then times 10 to the power of. So if the 1's in the units column, we would need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 columns to the left. So it'd be times 10 to the power of 9. So the answer would be 1.67485 times 10 to the power of 9. And it's very important you know where the standard form button is in your calculator. And also, I like to include brackets whenever I'm dealing with standard form in my calculator. Okay, let's look at our next question, question number 15. So question number 15 is a non-calculator question, so I'm putting the calculator down. And we've been asked to work out the answer to these and to give our answer in standard form. So we've got 4 times 10 to the power 5 multiplied by 2 times 10 to the power 4. So whenever I'm answering a question like this without a calculator, I like to look at the numbers in front of them multiplied by 10 to the power. So I like to look at the 4 and the 2 and multiply those to begin with. So 4 times 2 is equal to 8. So we've just times the 4 and the 2 together. And then I'm going to write times 10 to the power of. And then here we've got 10 to the power 5 times 10 to the power 4. I remember whenever we're dealing with multiplying things with the same base, you can add the powers. So 10 to the power 5 times 10 to the power 4, you would add the powers, that'd be 10 to the power of 9. So the answer would be 8 times 10 to the power of 9. And that's it. Now that question was quite nice because whenever we done 4 times 2 we got 8, and that number was between 1 and 10, so it was bigger than or equal to 1 but less than 10, so that meant that we could just write the answer down because it was in standard form. If for instance this number here was a 4 and we done 4 times 4 is 16, you'd have 16 times 10 to the power of 9, and then you'd need to make the 16 10 times smaller, but you'd need to make the bit with the 10 10 times bigger, so the answer would be the same. Okay, let's have a look at one like that now, part B. So part B, we've been asked to work out 5 times 10 to the power of 6 multiplied by 7 times 10 to the power of 8. So again, let's deal with the numbers at the front to begin with. So let's do 5 times 7. And 5 times 7 is equal to 35. And then we're going to have times 10. And now we've got 10 to the power of 6 times 10 to the power of 8. So we're going to add the powers together. And 6 plus 8 is equal to 14. So it'll be times 10 to the power of 14. Now we're almost there. 35 times 10 to the power of 14. It's almost like standard form, but this number needs to be between 1 and 10. It needs to be bigger than or equal to 1, but less than 10. So we're going to choose 3.5. We're going to make that number 10 times smaller. And if we make that number 10 times smaller, we're going to need to make this number 10 times bigger so that we get the same answer. And whenever you have 10 to the power of 14, if you make it 10 times bigger, you can just add 1 to the power. So it'll be to the power of 15. So the answer would be 3.5 times 10 to the power of 15. And that's it. And you can check that in your calculator. If you type that into your calculator, obviously it's a non-calculator question, but you can check it on your calculator and see if that's what you get. Okay, let's look at our next question. So question number 16. So we've got more questions, similar questions. This time we've got divisions rather than multiplications for A and B, and part C is just squaring. These are non-calculator questions, so I'm just putting down the calculator, and we're going to answer these questions, but again, we're not going to use a calculator. So we've got 3 times 10 to the power 4 divided by 6 times 10 to the power 3. So again, let's deal with the numbers at the front. So we've got 3 and 6, so we've got 3 divided by 6. And 3 divided by 6 is equal to 0.5. I know that straight away. If you do 3 divided by 6, you get 0.5. You could, if you want to, do the Bushell's method and do 3 divided by 6. So we're dividing by 6, so we know it's going to be a decimal number because 6 is bigger than 3. And just put in a decimal point, some zeros. How many 6s go into 3? 0, remainder 3. And how many 6s go into 30? That's 5. So it's 0.5. So 3 divided by 6 is 0.5. Then we've got our multiply by 10 to the power of. We now need to work out what the power is going to be. So we've got 10 to the power 4 divided by 10 to the power of negative 3. So remember, whenever we're dividing things with the same base, they've both got 10 as the base, but we're dividing, we're going to take away the powers. So we're going to do 4 subtract minus 3. And whenever you do 4 minus 3, you're going to do 4 plus 3 because you're taking away a negative, and 4 plus 3 is equal to 7. So we've got 0.5 times 10 to the power of 7. Now we're almost there. 0.5 isn't between 1 and 10, so we need to make this 10 times bigger. And if you take the 0.5 and you make it 10 times bigger, you're going to get 5. So making that 10 times bigger. And if you make that 10 times bigger, you need to make this 10 times smaller. And if you get 10 to the power of 7, if you divide that by 10, you'd have 10 to the power of 6. You just take away 1 from the power. So the answer would be 5 times 10 to the power of 6. And that's it. Okay, now let's look at our next part, question 16b. So question 16b, we've got 2.1 times 10 to the power of negative 5 divided by 7 times 10 to the power of negative 4. So again, let's deal with the numbers at the front to begin with. We've got 2.1 divided by 7. So we've got 2.1 divided by 7, just in the Bush-Shelton method there. How many 7s go into 2? 0, remainder 2. How many 7s go into 21? That's 3. So that's 0.3. So 2.1 divided by 7 is 0.3. So we're going to have 0.3 times 10 to the power of, and then we've got 10 to the power of negative 5 divided by 10 to the power of negative 4. So remember, whenever we're dividing things with the same base, you take away the powers. So we've got minus 5 minus minus 4. So if we have minus 5 and we subtract minus 4, that means you're going to be adding 4. So minus 5 plus 4 would bring us up to minus 1. So we're almost there. We've got 0.3 times 10 to the power of negative 1. But this isn't in standard form because this number needs to be bigger than or equal to 1 but less than 10. So we're going to make the 0.3 10 times bigger. So we're going to make that 3. And if we make that 10 times bigger, we need to make this 10 times smaller. So we're going to take away 1 from the power. Minus 1, take away another 1 would be minus 2. So the answer would be 3 times 10 to the power of negative 2. And the question said to give our answers in standard form. So as you can see, that's in standard form. Okay, and then part C. Part C, we've been asked to work out 5 times 10 to the power 4 squared. So whenever we're squaring something, we times it by itself. So we've got 5 times 10 to the power 4 multiplied by 5 times 10 to the power 4. And I'm just going to show you this way and then I'll show you another way. So because we've got squared, we're multiplying it by itself. So we're going to do 5 times 5, the number's in front, so that'll be 25. And then times by 10 to the power of. And then we're multiplying things with the same base, so we're going to add the powers, and 4 plus 4 is equal to 8. So we've got 25 times 10 to the power of 8. Now this isn't in standard form, so we need to make this number 10 times smaller, so that'll be 2.5 times 10. And then if we're making this number 10 times smaller, we need to make this number 10 times bigger. So instead of being to the power of 8, you add 1 onto the power, so it'll be to the power of 9. So the answer would be 2.5 times 10 to the power of 9. And that's it. So in this question, because the power was 2, we're squaring it, so we multiplied it by itself. Now, sometimes the power might be a bigger power. It might be a 2, but it might be a 3 or a 4 or a 5 or something like that. So I also want to show you that if you've got a power of 2, what you can do is you can just square what's in the brackets. So if we had 5 times 10 to the power 4 squared, well, 5 squared is 25 times 10. And here you've got a power of a power. If you've got a power of a power, you times the powers together. So 4 times 2 is equal to 8. So you could just do 5 squared is equal to 25, and 10 to the power of 4 squared, well, times the powers together, so that'll be 10 to the power of 8. And again, this isn't in standard form because this part needs to be between 1 and 10, bigger than or equal to 1, but less than 10. So we divide it by 10 to get 2.5, but we need to multiply this by 10, so you add 1 onto the power, so it'll be to the power of 9. And that's it. Okay, let's look at our next question, question number 17. So question number 17a says, write 0.0083 in standard form. So we want to write this number in standard form. So remember, we want a number between 1 and 10, so I'm going to choose 8.3 times 10 to the power of, and it's a small number, so it's going to be a negative power. And if the 8's in the units column, we would move it 1, 2, 3 columns to the right, so it'll be to the power of negative 3. Or we could just say there's 3 zeros at the front, so it's to the power of negative 3. Okay, now let's look at part B. So part B says work out 2 times 10 to the power of 4 over, or divided by, 5 times 10 to the power of 8. And we've been asked to give our answer in standard form. So what I'm going to do is I'm going to divide the numbers at the front and get that answer. And then I'm going to take away the powers because here we've got divided by, so we're going to do 10 to the power of 4 divided by 10 to the power of 8, so we can take away the powers. So 2 divided by 5. Now I know that 2 divided by 5 is equal to 0.4 because it's 2/5 and 2/5 is 0.4. Alternatively, we could do 2 divided by 5. Because the 5 is bigger than 2, we know it's going to be a decimal number. It's going to be a 0 point number. So how many 5s go into 2? 0 remainder 2. And how many 5s go into 20? That's 4. So as you can see, that's 0.4. Times 10, and then we now just need to get the power. We've got 10 to the power of 4 divided by 10 to the power of 8. We're going to take away the powers. 4 take away 8 is equal to minus 4. So we've got 0.4 times 10 to the power of minus 4. Now 0.4, that number needs to be bigger than or equal to 1 but less than 10. So I'm going to make it 10 times bigger. So that'll be 4 times 10 to the power of. And if we made that number 10 times bigger, we need to make this number 10 times smaller. And whenever we're making this 10 times smaller, we can just take 1 away from the power. So instead of being 10 to the power of negative 4, it's going to be 10 to the power of negative 5. We've made that 10 times smaller. So the answer is 4 times 10 to the power of negative 5. And that's it. Okay, let's look at our next question, question number 18. So question number 18, it's a calculator question, so I'm just going to turn on my calculator. And we've got the line here for fractions. I'm just going to press the fraction button, and I'm going to type this in. So I'm going to type in 6.32, and then press the standard form button, and then do it to the power of 13, and then press down, and now I'm on the denominator, and I can type in 1.6, the standard form button, and to the power of 8, and then press equals. And whenever I do that, I get an answer of 395,000. And now we just need to write the answer in standard form because 395,000 is an ordinary number. So it's going to be 3.95 times 10 to the power of. And if the 3 is here and it's in the units column, and we wanted to get to here, we're going to need to move it 1, 2, 3, 4, 5 columns to the left. And it's going to be to the power of 5. So our answer is 3.95 times 10 to the power of 5. And that's it. Okay, let's look at our next question, question number 19. So question number 19 says, Mr. Holland has got 2,500 kilograms of rice. And we've been asked to write 2,500 kilograms in grams and to give our answer in standard form. Okay, so to change from kilograms to grams, well, there's 1,000 grams in a kilogram, so we're going to times by 1,000. So if we take 2,500 and we multiply it by 1,000, we move those digits 3 columns to the left, or if you're just timesing a whole number by 1,000, you can just add 3 zeros, so 1, 2, 3. So we've got 2,500,000 grams. Now we want to write our answer in standard form. So that would be 2.5 times 10 to the power of. And then if the 2's in the units column, we would move it 1, 2, 3, 4, 5, 6 columns to the left, so it would be to the power of 6. And that's it. So 2,500 kilograms in grams and in standard form would be 2.5 times 10 to the power of 6 grams. And that's it. So we times by 1,000 and then just wrote that in standard form. Okay, and then part B. Part B says that 1 grain of rice has got a mass of 0.03 grams. And we've been asked to write the mass of 1 grain of rice in standard form. So we want to write this number in standard form. So it's 0.03 grams. So the number between 1 and 10 that we're going to choose is going to be 3 times 10. Now this is a small number, so it's going to be to the power of negative. And then if the 3 was in the units column, we would move it 1, 2 columns to the right, so it would be to the power of negative 2. Or there's 2 zeros at the front, so it would be to the power of negative 2. And that's it. Okay, and then part C. Part C says, how many grains of rice are there in 2,500 kilograms of rice? And to give our answer in standard form. So we want to work out approximately how many grains of rice there would be, and we need to give our answer in standard form. Now this is fantastic because we know how many grams of rice there are altogether. That's 2.5 times 10 to the power of 6 grams of rice. And we know the mass of 1 grain of rice, which is 3 times 10 to the power of negative 2. So if we divide the total mass by the mass of 1 grain of rice, we can see how many grains of rice it would be. So we just need to divide our two answers. So we're going to take the 2.5 times 10 to the power of 6, and we're going to divide that by 3 times 10 to the power of negative 2. And when we do that division, we'll find out how many grains of rice there would be. And we need to give our answer in standard form. Now let's go back up. It is a calculator question, or it is now. Whenever you go back to the practice questions, it'll be a calculator question now. And what we're going to do is we're going to type this into our calculator and work it out. So if we take our, and I'm just going to use brackets here, 2.5, standard form button, to the power of 6, and then go across and close brackets, and then divide by, open up brackets, 3, the standard form button, to the power of negative 2, and then close brackets and press equals, we get an answer of 83,333,333.333 and so on. Now I've been asked to give our answer in standard form, so we want a number between 1 and 10. So I'm going to choose 8.3 recurring. I'm just putting the little dot there to show that the 3 is recurring. And then I'm going to do times 10 to the power of. And then if the 8 was in the units column, we would move it 1, 2, 3, 4, 5, 6, 7 columns to the left. So it'll be to the power of 7. So how many grains of rice would there be? Well, approximately 8.3 recurring times 10 to the power of 7. And that's it. Okay, let's look at our next question, question number 20. So question number 20, part A says to write 5 million in standard form. So 5 million, that's a 5 followed by 6 zeros, 5 and then 1, 2, 3, 4, 5, 6. And if we wanted to write that in standard form, it would be 5 times 10 to the power of. And then because we know the 6 zeros and we've got 5 here, it would be to the power of 6. Because if you have 5 and you times it by 10 to the power of 6, which is a million, you'd get 5 million. Or again, you could consider the fact that 5's in the units column, we would move it 6 columns to the left, so it would be to the power of 6. Okay, and then part B. Part B says to write 300,000 in standard form. So it's 3 and then 5 zeros. 1, 2, 3, 4, 5. 300,000. And if we wanted to write that in standard form, it would be 3 times 10 to the power of. And because it's just 3 and we were just adding on 5 zeros, it would be to the power of 5. Or again, you could consider the fact that the 3's in the units column, it would move 5 columns to the left, so it would be to the power of 5. Okay, and then part C. Part C, we've been asked to work out 5 million multiplied by 300,000 and to give our answer in standard form. So let's look at our two answers and multiply those together. So let's do 5 times 10 to the power of 6. I'm just writing this down and then I'll scroll down. Multiplied by 3 times 10 to the power of 5. And then if we work that out, that'll be our answer. Okay, so let's scroll down. 5 times 3 is equal to 15, just doing the numbers at the front, and then multiplied by 10. And then we've got 10 to the power of 6 multiplied by 10 to the power of 5. So we're going to add the powers together, so that'll be 10 to the power of 11. So we've now got 15 times 10 to the power of 11, but we want this in standard form. So we want this number to be bigger than or equal to 1, but less than 10. So let's divide it by 10, so we get 1.5 times 10. Now we've made this number 10 times smaller, so we need to make this number 10 times bigger. So that means we're going to add 1 to the power, so it'll be to the power of 12. So the answer would be 1.5 times 10 to the power of 12. And that's it. Okay, let's look at our next question, question number 21. Okay, so question number 21 says a calculator displays a number in standard form, so it displays this number, and we've been asked to write the number as an ordinary number. Okay, so one way to this, because the power is -5, we know it's a very small number. And because the power is -5, we know there's going to be 5 zeros at the front. So it's going to be 1, 2, 3, 4, 5. And then we've got the 8 and the 1. And then we just need to put the decimal point in. So the answer would be 0.0000081. And that's it. Alternatively, we could think about it in terms of the fact that the 8's in the units, or the ones column. And we need to move it 5 columns to the right, so it would move 1, 2, 3, 4, 5 to there, and then that will be our answer. And that's it. Okay, let's look at our next question, question number 22. So part A says to work out 2.6 times 10 to the power of 6 plus 7.1 times 10 to the power of 5, and to give our answer in standard form. Okay, so whenever I'm doing questions like this, whenever I'm adding numbers in standard form, I like to just write them out in full and then to add them and then to write them back in standard form. So we've got 2.6 times 10 to the power of 6. So we're going to move the digits 6 columns to the left. So if we've got 2.6, we'd have 26. We've moved them 1 column to the left. Now we need to move them another 5 columns to the left. So let's add 5 zeros. 1, 2, 3, 4, 5. And then we've got 7.1 times 10 to the power of 5. So we'd move the 7 and the 1 column to the left, so it'd be 71, and then we'd add 4 zeros on because we need to move them 5 columns to the left altogether. So it'd be 7, 1, and then 4 zeros, 1, 2, 3, 4. And as you can see, we've lined up those numbers. If you wanted to, you could write them down as ordinary numbers to begin with, and then line them up, and then do the addition. So we're now going to do the addition. So 0 plus 0 is 0, 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 0 plus 1 is 1, 6 plus 7 is 13, so put a 3 down and carry a 1, and 2 plus 1 is equal to 3. So we've got an answer of 3,310,000, but we need to write the answer in standard form. So in terms of the number between 1 and 10, I'm going to choose 3.31, and then times 10 to the power of. And then if the 3 was in the units column, this first 3 was in the units column, we'd need to move it 1, 2, 3, 4, 5, 6 columns to the left, so to the power of 6. So the answer is 3.31 times 10 to the power of 6, and that's it. So whenever you're adding numbers in standard form or taking them away, like you'll see in a second, it can be easier actually just to write them out in full and to work them out. So here we've got 9.2 times 10 to the power of 5, subtract 8.3 times 10 to the power of 4. So let's write them as ordinary numbers to begin with. So this time we're going to write them down and then I'll line up the subtraction. So 9.2 times 10 to the power of 5, we need to move these digits 5 columns to the left. So 92, we move them 1 column to the left. We need to move them over 4, so let's add 4 zeros. 1, 2, 3, 4. And 8.3 times 10 to the power of 4, let's move them 1 column to the left to be 83. And then we need to move them over 3 columns to the left, so let's add on 3 zeros. So we've got 920,000 subtract 83,000. So let's line up our subtraction. 920,000 subtract 83,000. And then whenever we do that subtraction, we can get our answer and then write it in standard form. So 0 take away 0 is 0, 0 take away 0 is 0, 0, 0 take away 3, let's borrow. So we've now got 10 take away 3, which is 7. 1 take away 8, let's borrow again, so that's a 9, and now it's 11. 11 take away 8 is 3, and then 8. So our answer would be 837,000. In standard form, that would be 8.37 times 10 to the power of, and then if the 8 was in the units column, we'd need to move it 1, 2, 3, 4, 5 columns to the left, so it'll be to the power of 5, and that's it. So that's our answer in standard form. Okay, let's look at our next question, question number 23. So question number 23, we've been asked to work out the cube root of 8 times 10 to the power of 12. Now, there's a couple of different ways we can look at this. One approach is to figure out, well, if you're cube rooting something, you're trying to find what number do you multiply by itself and by itself again to get it. So we're trying to find out what number we would multiply by itself and by itself again to get 8 times 10 to the power of 12. Now, the cube root of 8 is equal to 2. So I'm going to choose 2 times 10 to the power of something, 2 times 10 to the power of something, and 2 times 10 to the power of something. Because 2 times 2 times 2 is equal to 8. So we've got the number at the front. Now we just need to figure out what the power would be. So here we've got 2 times 10 to the power of something, multiplied by 2 times 10 to the power of something, multiplied by 2 times 10 to the power of something. And remember, whenever you're multiplying things with the same base, you're adding the powers. So this number plus this number plus this number will have to equal 12. And it's the same number. So if you do 12 divided by 3, that's equal to 4. So it'll be to the power 4, to the power 4, and to the power 4. So the cube root of 8 times 10 to the power 12 would be 2 times 10 to the power 4. And that's it. Okay, let's look at our next question, question number 24. So question number 24 says the number of visitors to some tourist attractions are shown below in the table. So here we've got some tourist attractions. We've got the King's Palace, there was 5.4 million visitors. A castle which had 923,840 visitors. A theme park which had 1.43 times 10 to the power of 7 visitors. And a science museum which had 4,192,900 visitors. And part A says, write down the number of visitors to the theme park as an ordinary number. So at the minute it's in standard form, we want to write it as an ordinary number. So let's move these digits 7 columns to the left. So if we move them 2 columns to the left, we'd have 143, just moving those digits 2 columns to the left. But we need to move it 7 columns to the left, so if we move them 2, we need to move them another 5. So let's add 5 zeros. 1, 2, 3, 4, 5. And that's it. So it would be 1,430,000. 14,300,000. Okay, and then part B. Part B says write down the number of visitors to the castle in standard form. So we need to write down the number of visitors to the castle in standard form. So it's 923,840. And we want to write that in standard form, so that'll be 9.2384 times 10 to the power of. And if we have the 9 in the units column, we would move it 1, 2, 3, 4, 5 columns to the left, so it would be to the power of 5. So the answer would be 9.2384 times 10 to the power of 5. And that's it. And then part C. Part C says how many more people visited the theme park than the science museum. So the theme park, it had 14,300,000. We could write it in standard form as 1.43 times 10 to the power of 7. And the Science Museum, in terms of the number of visitors, was 4,192,900. And we want to work out how many more people visited the theme park than the Science Museum, so we're going to take them away. And this is a non-calculator question. Yep, non-calculator question. So I'm going to do this number, take away this number. Now we've already written this as an ordinary number. It was 14,300,000. So let's write it out again. 14,300,000. Take away 4,192,900. And when we take them away, that'll be how many more people visited the theme park than the Science Museum. So let's do that. 0 take away 0 is 0. 0 take away 0 is 0. 0 take away 9, we're going to need to borrow, so cross the 3 out, make it a 2. That's now 10. Borrow again, a 9 and a 10. Borrow again, a 9 and a 10. 10 take away 9 is equal to 1. 9 take away 2 is equal to 7. 9 take away 9 is equal to 0. 2 take away 1 is equal to 1. 4 take away 4 is equal to 0, and then we've got the 1. So there was 10,107,100 more visitors to the theme park than the Science Museum. And that's it. Okay, let's look at our next question. So question number 25. Question number 25 says the number of loaves of bread baked each year by 5 companies are shown below. So we've got Mavis, Norton's, Green Mill, Dan the Baker, and Bread World. And we've got the number of loaves that they bake each year. And then it says, Jensen says that Bread World, so Bread World, this one here, baked approximately twice as many loaves as Dan the Baker. So he's saying that Bread World baked twice as many loaves, approximately twice as many loaves as Dan the Baker. Is Jensen correct? And explain our answer. So he's saying that Bread World baked twice as many, approximately twice as many loaves as Dan the Baker. Okay, now this is actually a calculator question. So what I'm going to do is I'm going to take the number of loaves of bread baked by Bread World, this 8.07 times 10 to the power of 7, and I'm going to divide it by the number of loaves of bread that Dan the Baker baked, and then we'll see how many times greater it is. And if we get an answer that's close to 2, then we'll know that Jensen is correct. So let's do that. So let's take 8.07 times 10 to the power of 7, and let's divide that by 4.02 times 10 to the power of 6, and let's see what we get. So when we type that into our calculator, we've got 8.07 times 10 to the power of 7, and then close brackets, divided by, and open up brackets, 4.02 times 10 to the power of 6, and then close brackets. That's equal to 20.0746, and so on. It's actually a lot more than twice as many loaves. It's actually just slightly over 20 times as many loaves. So Bread World baked over 20 times as many loaves of bread as Dan the Baker. So is Jensen correct? No. And I've just explained that no, actually Bread World baked over 20 times more than Dan the Baker, not twice as many. Okay, and then part B. Part B says find the mean number of loaves of bread baked by the companies. So to find the mean, we add up all the values and divide by the number of values. So what we're going to do is we're going to add up the number of loaves baked by each of the companies and then divide by 5. Now it's a calculator question, so that's quite nice. We can add these values up and see what we get. And when we add all those values up, we get that's equal to 238,410,000. So my calculator's given it to me as an ordinary number. If we just put our commas in, we'll see that's 238,410,000 loaves of bread. So that's the total, and then we just need to divide it by 5. So let's write it down. So we've got 238,410,000 loaves of bread, and if we divide that by 5, that's equal to 47,682,000 loaves of bread. And that's it. Now the question didn't say we need to give it in standard form, so I'd actually just write it like that, 47,682,000. And that's it. If you did write the answer in standard form, now you weren't asked to, but if you did, it would be 4.7682 times 10 to the power of 1, 2, 3, 4, 5, 6, 7 to the power of 7. So either one of those would be totally fine. I probably would just give it as an ordinary number. Okay, let's look at our next question. So question number 26, we've got this table, we've got the planets of the solar system and the circumference of those planets, and then we're asked in part A, which planet has the largest circumference? We need to find the largest circumference. So it's going to be times 10 to the power of 8 rather than times 10 to the power of 7. So it's going to be one of these 4 planets here. And because we've all got times 10 to the power of 8, we're looking for the one with the biggest number at the front, so it'll be this one, Jupiter. So Jupiter's got the largest circumference, so Jupiter. And then part B says which planet has the smallest circumference. So we're going to be looking at the ones with times 10 to the power of 7. So one of these 4. And the smallest circumference, well, we're looking for the one with the smallest number at the front, so that'll be Mercury. So Mercury's got the smallest circumference, so Mercury. Okay, and then part C. Part C, we've been asked to write 1.54 times 10 to the power of 7 as an ordinary number. So to write this as an ordinary number, we need to move these digits 7 columns to the left. So moving them 2 columns to the left would be 154, moving those digits 2 columns to the left. We need to move it 7 altogether, so we've moved them 2, so we need to move them down another 5, so let's add on 5 zeros. So 1, 2, 3, 4, 5. So it'll be 1, 5, 4, 0, 0, 0, 0, 0. And then part D says work out the diameter of Neptune, and we need to give our answer in standard form. Okay, so we want to find the diameter of Neptune. So we know the circumference of Neptune. If we go back up, the circumference of Neptune is 1.55 times 10 to the power of 8. So 1.55 times 10 to the power of 8. That's the circumference. Now we want to find the diameter. So circumference is pi times diameter. So to get the circumference, we times the diameter by pi. So we do pi times diameter, and then this would be the answer. So if we want to go backwards and find the diameter, we need to divide by pi. So let's take the 1.55 times 10 to the power of 8 and let's divide it by pi. So let's divide by pi and see what we get. So it's a calculator question, so I'm going to do 1.55. I'm just going to open up brackets, 1.55 times 10 to the power of 8 and then close brackets, divided by pi is equal to 4933803.36. So we've got this. Now I'm actually just going to round this. I'm going to round it to 4 significant figures. So I'm going to round this to 4 significant figures. So that'll be 493. And then the 4th significant figure would round up there to be 4 and then 0, 0, 0, 0 meters. And then let's write this in standard form. So that'll be 4.934 times 10 to the power of, and then we've got the 4, let's move it 1, 2, 3, 4, 5, 6, 7 columns to the left. So the diameter of Neptune would be 4.934 times 10 to the power of 7 meters, and that's it. Okay, so let's have a look at our next question, question number 27. So question number 27 says the distance of the moon to the Earth is 384,400 kilometers, and the speed of light is 2.998 times 10 to the power of 8 meters per second. And the question says work out how long it would take light to travel from the moon to Earth, and to include suitable units. Okay, so here we know that the speed of light is 2.998 times 10 to the power of 8 meters per second. So let's change the distance into meters. So it's in kilometers, so let's multiply that by 1,000, so that'll be 384,400, so that's kilometers. We're going to times by 1,000, so we'll add on 3 more zeros, so 1, 2, 3 meters. So that's the distance between the Earth and the moon in meters. Now what we're going to do is we're going to divide the distance by the speed, because time is equal to distance divided by speed. If you divide the distance by the speed, you'll get the time. So if, for instance, I was driving 60 miles at a speed of 30 miles per hour, I would do 60 divided by 30, which is equal to 2, so it would take 2 hours. So in this question, we're going to divide the distance by the speed. So we're going to take our 384,400,000, so that's the meters, and divide that by 2.998 times 10 to the power of 8. So let's do that. So I'm going to get my calculator. I'm going to press the fraction button, type in the numerator 3844,000,000, and then on the denominator I'm going to type in 2.998 and then the standard form button to the power of 8, and then press equals. And that gives me an answer of 1.282188 and so on seconds. And I'm just going to round that to 2 decimal places. It would take 1.28 seconds, and that's it. So that's how long it would take. Okay, let's look at our next question, question number 28. Okay, so question number 28, we're told that A, B, and C are standard form numbers. So we've got A, B, and C. And part A says we need to calculate B subtract A. So we need to do B subtract A. So we're going to do 4.9 times 10 to the power 5, subtract 5.4 times 10 to the power 4. That's a non-calculator question, so I'm just going to write them out in full. So I've got the 4.9, I'm going to move them 5 columns to the left, so 49. I've moved those digits 1 column to the left. Now another 4, 1, 2, 3, 4. In terms of 5.4 times 10 to the power 4, I need to move those digits 4 columns to the left. So moving them 1 column to the left would be 54, and then another 3. 1, 2, 3. So A is equal to 54,000, and B is equal to 490,000. And we need to do B subtract A. So that's 490,000 subtract 54,000. And let's see what we get. So 0 take away 0, 0, 0 take away 0, 0, 0 take away 0, 0, 0 take away 4, let's borrow. So we've now got an 8 and a 10. 10 take away 4 is equal to 6. 8 take away 5 is equal to 3, and then our 4. So we've got 436,000. So 436,000. That's what B subtract A would be. You could, if you wanted to, write 4.36 times 10 to the power 5. If you wanted to, either one of those would be fine. Okay, part B. Part B says to calculate C squared. So C is equal to 4 times 10 to the power of 6. So we need to do 4 times 10 to the power of 6 all squared. 4 times 10 to the power of 6 multiplied by 4 times 10 to the power of 6. 4 times 4 is equal to 16. And then we'd have 10 to the power of 6 multiplied by 10 to the power of 6. We would add the power, so it would be times 10 to the power of 12. Now, the question didn't say we need to write an answer in standard form, so we could at this point just write, because we've got 16 times 10 to the power of 12, that's 16, followed by 12 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you could write out like that if you wanted to. Alternatively, if you are going to write it in standard form, this isn't in standard form because the number needs to be between 1 and 10. You take the 16, you divide that by 10, so that'll be 1.6. So it's this answer or this answer. So 1.6 times 10. Now we've divided this number by 10, so we need to multiply this number by 10, so it'll be to the power of 13, just adding 1 to the power. So the answer would either be 16 followed by 12 zeros or 1.6 times 10 to the power of 13. And that's it. Also here, just remember that here if you're squaring, you could do 4 squared is equal to 16 and then just multiply the powers together. So it'll be 16 times 10 to the power of 12, and then you can either get your answer in standard form or as an ordinary number. Okay, and then part C. Part C, we've been asked to calculate AC. So let's write down what A and C are. So A is 5.4, so 5.4 times 10 to the power of 4. That's what A is equal to. So A is equal to that. And C is equal to, let's just go up and check that. That's A. And C is equal to 4 times 10 to the power of 6. So 4 times 10 to the power of 6. And we need to work out AC, which is A times C. So let's multiply these together. So we're going to do 5.4 times 10 to the power of 4 multiplied by 4 times 10 to the power of 6. Okay, so let's take the numbers at the front and times them together. So we're going to do 5.4 times 4. So to times by 4, I just tend to double and double it again. So doubling 5.4 would be 10.8, and doubling that would be 21.6. So 21.6, just doubling and doubling again, times 10 to the power of, and then just add the powers together. 4 plus 6 is equal to 10. So we've got 21.6 times 10 to the power of 10. Now at this point, you could just move those digits 10 columns to the left and write it as an ordinary number. I'm just going to write this one in standard form. It's just a little bit easier. We could divide this by 10 to get 2.16. And if you divide this number by 10, you need to multiply this one by 10. So you need to increase the power by 1. So it'll be 2.16 times 10 to the power of 11. And that's it. Okay, let's have a look at our next question, question number 29. Now, question number 29 is a calculator question, and we're told the population of England is 5.604 times 10 to the power of 7. And the number of people who live in London is 8.982 times 10 to the power of 6. So let's write down what fraction of the people that live in England live in London. So that would be, in terms of the numerator, that would be how many people live in London, which is 8.982 times 10 to the power of 6. out of all the people, which is 5.604 times 10 to the power of 7. So we've written it as a fraction. Now we need to write it as a percentage. So let's just change it to a decimal. So let's do the numerator divided by the denominator. So on my calculator, I'm just typing in on the numerator 8.982 times 10, well, pressing the standard form button, times 10 to the power of 6. And then on the denominator, 5.604, the standard form button to the power of 7. And then if we press equals, we get that's equal to 0.1602783 and so on. Now that's a decimal. We want it as a percentage, so let's multiply that by 100 to get 16.02783 and so on. Now we've been asked to give our answer to two decimal places, so that'll be 16.0, and then we want it to two decimal places, so we've got 2 7s, so we're going to round up, so that'll be 3. So the answer is 16.03% of the people that live in England live in London, whenever this question was made. Okay, let's look at our next question, question number 30. Okay, so question number 30, we've been asked to work out 2.19 times 10 to the power of 8 multiplied by 3.52 times 10 to the power of 3, and to give our answer in standard form. So it's a calculator question, so we can just type this in. I'm just going to put in brackets 2.19, the standard form button, to the power of 8, and then close brackets, multiply by, open up brackets, 3.52, the standard form button, then 3, then pressing to the right, and closing brackets and pressing equals, gives us 7.7088 times 10 to the power of 11. And that's it. And the calculator gave that answer in standard form for me, so I just needed to write it down. And that's it. Okay, so question number 31. Question number 31, we've been asked to work out 4.5 times 10 to the power of 7 divided by 5 times 10 to the power of negative 2, and to give our answer in the standard form. And it's a non-calculator question, so I'm just putting the calculator down. So here we've got a division. So let's divide the numbers at the front. So we're going to do 4.5 divided by 5. So 4.5 divided by 5. So how many 5s going to 4? 0 remainder 4. And how many 5s going to 45? That's 9. So that would be 0.9 times 10 to the power of, and now we just need to, because we're dividing things with the same base, we take away the powers. 7 subtract minus 2, well, it's going to be 7 minus 2 means we can add 2, which would be 9. So it's going to be 0.9 times 10 to the power of 9. Now we want to give our answer in standard form, and this number at the front needs to be bigger than or equal to 1, but less than 10. So let's make it 10 times bigger. So it's going to be 9 times 10 to the power of. And if we make this number 10 times bigger, we need to make this number 10 times smaller. So that means we're going to take 1 away from the power, so it'll be to the power of 8. So it's going to be 9 times 10 to the power of 8. And that's it. Okay, let's look at our next question, question number 32. So question number 32, part A, says to write this number in standard form. I'm not going to try reading it out. Well, I could have put commas in and so on, but we're not asked to. So here we've got 593. So in terms of the number at the front, I'm going to go for 5.93 times 10 to the power of. And then if we've got the 5 in the units column, we'd need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 columns to the left. So all those digits would need to move 9 columns to the left to get this number. So the answer would be 5.93 times 10 to the power of 9. Okay, and then part B. Part B, we've been asked to write 8.024 times 10 to the power of negative 4 as an ordinary number. So we want to write this as an ordinary number. Because it's got a negative power, we know it's going to be a very small number. And remember the shortcut that here we've got a power of negative 4, so that means we're going to put 4 zeros down, 1, 2, 3, 4, and then write the rest of the number, so 8024. Just writing this part then after it, and then put the decimal point in. So it'll be 0.0008024. And that's it, we've written that as an ordinary number. Or alternatively, because the power is a negative 4, you know it's going to be a small number, so those digits are going to move 4 columns to the right. So the 8 would move into the tenths, then into the hundredths, then into the thousandths, then into the 10,000ths. That's there. And then 0, 2, 4. And that's it. Okay, and then let's carry on. We're told then that C, W, and Y are positive numbers, that C is equal to 2 times 10 to the power of 9, and that Y is equal to 6 times 10 to the power of 5, and that W squared is equal to CY over C subtract Y. And we've been asked to work out the value for W, so it seems quite complicated, but we want to find the value for W. And we want to give our answer in standard form, correct to 2 significant figures. Okay, so here we've got the values of C and Y, so let's substitute them into this to find out the value of W squared. So we've got CY over C subtract Y. And let's just check, is it a calculator question? Yeah, that's fantastic. So what I'm going to do is here, I'm going to write that W squared is equal to C times Y, so it's going to be on the numerator, 2 times 10 to the power of 9 multiplied by y, which is 6 times 10 to the power 5. So that's what we're going to type in on the numerator of the fraction, and then over, and then we're going to do c subtract y. So c is 2 times 10 to the power of 9, subtract 6 times 10 to the power 5. And then we're just going to type this in and into our calculator and then press equals, and that'll give us what w squared is. So let's do that. So when we type that into our calculator and press equals, we get an answer of that w squared is equal to 600,180.054. So we now know that w squared is equal to 600,180.054. So we want to figure out what number, whenever you square it, gives us this answer. Now it has to be a positive number because in the question it says they're positive numbers. So what we're going to do is we're just going to square root this. If we do the square root of answer, if we do the square root of 600,180.054, that'll tell us what w is. And that's equal to 774.712 and so on. Now the question says work out the value for w, so we've got it, and give our answer in standard form correct two significant figures. So let's round this to two significant figures. That would be 770 to two significant figures, and in standard form that'll be 7.7 times 10 squared, and that's it. That's what w is. Okay, let's look at our next question, question number 33. So question number 33, we've been asked to work out 1.5 times 10 to the power of 6 plus 5 times 10 to the power of 5 multiplied by 3 times 10 squared, and to give our answer in standard form. So here we've got an addition and we've got a multiplication. And remember our order of operations. We need to do our multiplications before we do any additions. So let's do this multiplication first. So 5 times 3, just times in the numbers at the front, 5 times 3 is equal to 15, times 10, and then we're going to add the powers because they've both got a base of 10. We add the powers. 5 plus 2 is equal to 7. So whenever we do 5 times 10 to the power of 5 multiplied by 3 times 10 to the power of 2, we get 15 times 10 to the power of 7. Now this isn't in standard form. In standard form that would be, we would divide that by 10 to be 1.5, but if we make that 10 times smaller, we need to make this 10 times bigger, so it'd be 10 to the power of 8. So we've worked out that if we multiply these two things together, we get 1.5 times 10 to the power of 8. So that's that part, but we've still got our addition, so we need to add, so that plus we've got our 1.5 times 10 to the power of 6, and we need to add that and that together. So whenever we're adding numbers in standard form, I like to write them out in full. So here we've got as ordinary numbers. So here if we write this out in full, if we move these digits 6 columns to the left, moving them 1 column to the left would give us 15, and then another 5, so let's add 5 zeros, 1, 2, 3, 4, 5. And then we've got plus, and then 1.5 times 10 to the power of 8, let's move them 1 column to the left, so it'll be 15, and then another 7 would be 7 zeros, 1, 2, 3, 4, 5, 6, 7. So we've got this number plus this number. Let's line them up. We've lined them up, now we just need to add them. 0 plus 0 is 0, 0, 0, 0, 0, and then 5, 1, 5, 1. And then in standard form, that'll be 1.515 times 10 to the power of, and then if the 1's in the units column, it would move 1, 2, 3, 4, 5, 6, 7, 8 columns to the left. So the answer would be 1.515 times 10 to the power of 8, and that's it. Okay, let's look at our next question, question number 34. So question number 34 says the Earth is approximately a sphere of diameter 12,742 kilometers, and the surface area of a sphere is given by the formula the surface area is 4 pi r squared. So to find the surface area of a sphere, you do 4 times pi times the radius squared. And we've been asked to calculate the surface area of the Earth and to give our answer in square meters and in standard form. So we want to give our answer in square meters and in standard form. Okay, so the first thing I've noticed is that the diameter that they've given us is in kilometers. So let's multiply that by 1,000 to get it into meters. So that would be 12742,000 meters. So that would be the diameter of the Earth in meters. So it would be 12,742,000 meters. Now we want to find the radius, because to find the surface area is 4 multiplied by pi multiplied by the radius squared. Now we need to find the radius. So that means we need to half the diameter to get the radius of the Earth. So let's take the 12,742,000 meters, and then let's divide that by 2 to find out what the radius of the Earth would be in meters. And whenever you divide by 2, you get an answer of 6,371,000 meters. So that's the radius of the Earth. So now we know what the radius is in meters. When we work out this formula and we work out the surface area of the Earth, we're going to get our answer in square meters. That's fantastic. So now we just need to substitute in the radius into the formula to work out the surface area. So the surface area of the Earth is 4 multiplied by pi multiplied by the radius, which is 6,371,000, then squared. And when we type that into our calculator and press equals, we get an answer of 5.10064 and so on times 10 to the power 14. Now I'm just going to round this to two significant figures, so that'll be 5.1 times 10 to the power 14 meters squared, or square meters. And that's it. So we've found the surface area of the Earth in square meters and in standard form. And that's it. And that's it. So in this video, we've gone through the video solutions to the Corbettmaths Practice Questions on standard form. I really hope you found this video useful, and if you have found it useful, please like it and please subscribe to the YouTube channel. Also, if you need any extra help in standard form, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video numbers 300 to 303, there's dedicated video tutorials there on standard form. Alternatively, you could scan this QR code. But again, if you found this video useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.